Hello everyone, myself Hiren Patel, Assistant Professor at LJ Institute of Engineering and Technology. So in this current video lecture series, we are studying subject of Physics Group 1. So in previous videos, we have discussed about the first chapter, namely ultrasonic and NDT. So in this video, we are going to start the second chapter of Physics Group 1, and that is properties of matter. So in this video, we are covering the topics such as introduction to this chapter, concept of load and its classification, concept of stress and strain, and at the end we will discuss Hooke's law, which will be used in next session in stress and strain diagram. So let's start with the first topic of today's session, that is introduction about this chapter. So first of all, we will discuss various properties of material like elasticity, ductility, plasticity. But from these properties, elasticity is a branch of physics which deals with the elastic property of materials. So elasticity is the property by virtue of which bodies regain original shape and size after removal of deforming force. So when a deforming force acts on a body, there is a change in its length or shape or volume. Then the body is said to be strained. So in this chapter, we will discuss various elastic properties of materials and their behaviors. Also, we will discuss some important derivations related to dorsal pendulum and cantilever beam. So let's start with the first topic, that is concept of load. So load is nothing but the pressure. So here we will start with the first load, that is static load. So it is a load which is relatively constant for an extended time is called as static load. Dead load is referred as static load. So we can say that the magnitude of load remains constant with respect to time. Then that load is known as static load. Next is dynamic load. So it is exactly opposite to the normal load. So in dynamic load, that is varies with respect to time. So we can say that magnitude of that load continuously or varies with respect to time. So wind load, earthquake load are examples of dynamic load. Now next is normal load. So the load which acts as perpendicular to the cross-sectional area is known as normal load. So if we consider any body, then that normal load is acts as perpendicular to the cross-sectional area. So normal load is either tension or compression. Okay. So it produces linear deformation. Now next load is shear load. So the load which tends to produce a sliding failure of a body along a plane parallel to the direction of load or force is known as shear load. So we can say that in this type of load, orientation of body is changed. So we can measure it as an angle also. So in this load, there is a sliding failure of a body along a plane. So we will discuss in detail at the time of shearing stress. So now next load is concentrated load. So the load which is concentrated at a point is called as concentrated load. So if we consider this surface and if we applying force at particular point, then that load works as concentrated load. Now next is distributed load. So the load which is distributed over the length or area of the number is called as distributed load. Here we can say that this load divided in two parts, uniformly distributed load and uniformly varying load. So in first case, in case of uniformly distributed load, the magnitude of forces or load remains same on all over the surface. But in uniformly varying load, the load varies with respect to time on all over the surface. So these two are the examples of distributed load. Now let's move further. Concept of stress and strain, which will very useful in stress strain diagram. So you might be aware about basic definitions of stress and strain. So we will start with stress. So it is also defined as restoring force per unit area. So you can see in the slide that sigma is equals to F by A, where F stands for force and A stands for area. Now we will discuss types of stress. So longitudinal stress, volumetric stress and tangential stress are the types of stress. So we are going to discuss these three types of stress in detail. So let's start with first stress, that is longitudinal stress. So here you can see in the figure, there are two figures. In first image there is a tensile stress and in second image there is a compressive stress. So basically we can say that longitudinal stress can be compressive or tensile. So as you can see in the figure that in tensile stress, length of that sample will increase, and in compression stress, length of the sample is decreasing. So these are the two types of longitudinal stress. Now volumetric stress, it is also known as bulk stress. So volume stress is nothing but pressure, because to change the volume, force must be applied normal to the surface. Here we are dealing with the change in volume. In previous stress, in longitudinal stress, the length will change. But here in the case of volumetric stress, the change in volume occurs. So we have to apply the force normal to the surface. So here you can see in the figure, you can see that diameter corresponding to original volume of the object is inside, and diameter corresponding to the volume of object as a result of pressure acting on it. So here there are two cases: before applying the pressure and after applying the pressure. So by applying that pressure, we can achieve a change in volume, and that is nothing but volumetric stress. It is also known as bulk stress. Now last one is tangential stress or shear stress. So as we have discussed that shear load, in case of this stress, the orientation of sample will change. So we can say that in tangential stress, shape of sample will change. So by measuring that angle, we can achieve that how how much stress will apply. So it is also known as shear stress. So here you can see in the figure that there is a orientation of sample, of the position of the sample, or we can say that shape of the sample. So before this shape and after this stress, the shape of sample will change, and that type of stress is known as shear stress. Now the next is strain. So it is defined as the ratio of change in dimension to the original dimension. So there are three types of strains. Here, as you can see in the side, there is a longitudinal strain, volume strain, and tangential strain. So these three words is similar as stress. So longitudinal strain, we can say that in longitudinal strain there is a change in length occurs. So it is nothing but the ratio of change in length to original length. In case of volume strain, we can say that volume strain is nothing but the ratio of change in volume to its original volume. And similarly, tangential strain, here you can see in the figure that in tangential strain the shape of the sample will change. So by measuring that angle, we can achieve the shear stress. So it is also known as shearing strain. So these three are the types of strain: longitudinal strain, volume strain, and tangential strain. Okay. So now moving further to the next topic, and that is Hooke's law. So it states that stress is proportional to the strain for a small stress applied. So here it is also said that the ratio of stress to strain is constant. It is also known as coefficient of elasticity or modulus of elasticity. So you can see here that stress is directly proportional to the strain. So basically that ratio stress by strain is nothing but the coefficient of elasticity. So we can see that Hooke's law is also a part of stress strain diagram. So in this video we have discussed about the concept of load, types of load, stress, types of stress, strain, and types of strain. Now in next video we will learn stress strain diagram, important properties of material such as ductility, brittleness, and plasticity. We will also discuss working stress and factor of. So that's it for today's session. Thanks for watching.